What is the value of this expression? Well, we have 3 plus 1 over 3 plus 1 over 3 plus 1 over 3. All right, so let's do this. So the first one, I guess if we just add this guy, that's going to be 3 over 1. So multiply common denominator, that's going to be 10 over 3. Okay. So then this becomes 3 plus 1 over 3 plus 3 over 10, right? You just invert. And then we add that fraction, and we get 10 times top and bottom, so 33 over 10. And then this just becomes 3 plus 10 over 33, since you just invert it. And then now we get top and bottom 33, so it'll be 99 plus 10, so 109. 109 over 33 would be the answer, and that is D. The sum of three numbers is 96. The first number is 6 times the third number. Third number is 40 less than the second number. What is the absolute value of the difference between the first and second numbers? So A plus B plus C, that sum is 96. A is equal to 6C, and C is equal to B minus 40. So let's substitute that into here. And when we do, we get 6C plus B, which is C plus 40, plus C. And that's 96. So this will be 8C is equal to 56, sorry. And therefore C is 7. So if C is 7, that means A is 42. And therefore B would be 47, I believe. And what they want is A minus B, but when they want the absolute value, so that's going to be 42 minus 47, and that's going to be 5 when you take the absolute value. So the answer is E. Five rectangles, A, B, C, D, E, are arranged in a square as shown below. These rectangles have dimensions 1 by 6, 2 by 4, 5 by 6, 2 by 7, 2 by 3, respectively. Which of the 5 rectangles is shaded one in the middle? All right. So first let's list them. We have 1 by 6, so that would be 6 as the area. We have 2 by 4, which would be an 8 as the area. A 5 by 6, which is 30. A 2 by 7, which is 14. And finally a 2 by 3, which is a 6. So when you add up these areas, they give you 64. Now this is a square, so that means it's an 8 by 8 square. That's the only way you'd get that 64. Okay, so that's good. That helps us out a little bit, that this is going to be 8, and this is also going to be 8. Okay, so then you just have to fiddle around with this. So let's see here. If I put this guy, this looks like a 1 by 6 to me, so I'm going to call that A. Then this is going to be 2, since the sides are 8 by 8, since it's a square. So 2, like I said, you got to kind of take a chance here. I'm going to take a chance and put a 2 by 3 here. So that's going to be this guy, E. And if it doesn't match up, we can try again. So then that means this is 5, since this whole thing has to add up to 8. And the only one that has a 5 is this guy here. So that means this must be the 5 by 6 one. So that's a C. And then now we're just down to a couple. So this is a 7. We know that for sure, since that has to this is 1. And that has to add up to 8. So the 7 by 2. And yeah, this 2 and the 6 add up to 8. Okay, good. So everything matches up. So this is D. And therefore, the only one left was this B, and that's the 2 by 4, and that's obviously the one in the middle. And therefore, B is the answer to this question. The least common multiple of a positive integer n, and 18 is 180. The greatest common divisor of n and 45 is 15. What is the sum of the digits of n? All right. So we have the least common multiple of n and 18 is equal to 180. So LCM of n and 18 is 2 to the power of 1 times 3 to the power of 2. And 180 is 2 to the power of 2 times 3 to the power of 2 times 5 to the power of 1, correct? All right. So when you're trying to figure out the least common multiple, you think biggest. Now, I know that's paradoxical, but that's how you do it. Now, when I say think biggest, think of the biggest powers of each of those prime numbers. So in order to get the 2 to the power of 2, it had to be from here or here. Well, it's obviously not here, so it had to be from here. So that means that n has to have a 2 to the power of 2 in order for this to work. In order to get this 3 to the power of 2, it obviously came from here. So there we go. And to get this 5 to the power of 1, well, there is no 5 to the power of 1 here, so it had to have come from that n. So that n has in it at least a 2 to the power of 2 and a 5 to the power of 1. Okay, so now let's turn our attention to this GCD of n and 45, and that they're saying is 15. Okay, so same thing, GCD of n and 45 is what? 9 times 5, so that's 3 to the power of 2 times 5 to the power of 1, and that is equal to 15. Okay, well, 15 is 3 to the power of 1 times 5 to the power of 1, and for GCD, you think smallest this time. Smallest powers. So to get the 3 to the power of 1, the smallest must have come from that n, so that n has the 3 to the power of 1. And to get the 5 to the power of 1, well, that came from there. So that means this n has to have a 3 to the power of 1, and over here we realized that it had to have at least a 2 to the power of 2 and a 5 to the power of 1. So that n is at least a 2 to the power of 2 times 3 to the power of 1 times 5 to the power of 1, and when you do that math, it's 60. And they want the sum of the digits of that, so that's 6 plus 0, which is just 6. So the answer is B for this question. The taxi cab distance between points x1 and y1 and x2, y2 in the coordinate plane is given by x1 minus x2 absolute value plus y1 minus y2 absolute value. For how many points P with the integer coordinates is the taxi cab distance between P and the original origin less than or equal to 20? All right. So basically we have a situation where, let's say, draw a little graph here and say this is x1 and this is x2, and say this is y1 and this is y2. The taxi cab difference is going to be x1 minus x2, so that's going to be this, an absolute value, meaning it's got to be a positive value because we're talking about a distance. And then again, you take the same y2 minus y1, and then you get the absolute value. So if we're starting here and we're ending there, it's basically the distance from here to there, and then the distance from there to there. So I guess like if you're driving in a taxi between 2 points that are connected by roads, I guess. Okay, so they're basically saying that for how many points P with integer coordinates is the taxi cab distance between P and the origin less than or equal to 20. So if it's less than or equal to 20, that means you're going to have this situation where 20 is sort of the farthest you can go on the axis, and all the other points will be between those 2 points. And that basically will happen in all 4 quadrants like that. I mean, this isn't drawn in scale, but well, this is minus 20, and this is minus 20. Now, here's the thing. The integer coordinates means you're starting at 0, and then you're going 1, 2, 3, all the way up to 20. So you're actually going to have 21 integer points, right? From 0 to 20 inclusive. And the same thing on the y-axis. So if you have 21 on the x-axis and 21 on the y-axis, you have 21 times 21, which is 441. But this is a half of that total 21 times 21, right? Because it's just a triangle. So this is really 441 divided by 2. This 441 divided by 2 in terms of the number of points with integer coordinates, also known as lattice points. But you have 4 of these such regions, so it would be 4 times 441 over 2, and that is 882. But none of the answer choices are 882. So you say, well, what do I do here? Well, you have to sort of approximate, because if you notice, we actually double counted a little bit. We have to subtract these overcounts, because all the points along that red line that I just drew would be in this section, but they would also be in that section, so they're double counted. You see what I mean? So you're going to have to subtract from this 21, and then you probably have to subtract another 21 for the double counts here, and there's double counts there, blah, blah, blah. So if you bring those double counts down, you actually probably only have to subtract it twice, would be my guess. So it would be about 840. So the best choice of these is this guy right here. So this is a quick sort of estimation method of solving number 5. A data set consists of 6 not distinct positive integers, 17525x. The average arithmetic mean of the 6 numbers equals a value in the data set. What is the sum of the possible values of x? All right. So we have 17525 and x. And if we add them all up, 1 plus 7 plus 5 plus 2 plus 5 plus x divided by 6, we will get the average. And we have to do it for each one. So first we do it for 1, and then we'll do it for 7, and then we'll do it for the next one, which is 5, and then for 2, and then finally for x. And then we figure out what is the value for x for each of these. When you do it for 1, I'll let you do this. It's fairly straightforward. You get x equals to minus 14. But they want, let's see here, positive value. So this one we are not going to actually use. When you do this for 7, it's actually 20 plus x over 6. We get x equal to 22. So that is something we're going to use because it's positive. When you do this for 5, you get x is equal to 10. So that is positive, so you're going to use that. When you do this calculation for 2, you get 20 plus x over 6, and therefore you get x equal to negative 8, but then you don't use that because we need positive ones. And then finally 20 plus x over 6 is x, and this one will give you a value of x is equal to 4. So I use this. So 22, 10, and 4, and when you add those up, you get 36. So 36 is the sum of all the positive values of x. A rectangle is partitioned into 5 regions as shown. Each region is to be painted a solid color, red, orange, yellow, blue, or green, so that regions that touch are painted different colors. And colors can be used more than once. How many different colorings are possible? All right, well, let's talk about this. Red, orange, yellow, blue, or green. Let's take it one step at a time. For this first one, you can put any of those 5. So you have 5 choices. Right? Now for this next one, we cannot put the color that we put in this first one because the regions that touch are painted different colors. So here we can only put one of 4 choices because this first color cannot be put there. Then this next one, we can't put what we put here, and we can't put what we put here. So that's 2 colors of these 5 that we cannot choose. So we have 3 choices remaining. For this region here, we cannot put what we put here, and we cannot put a color that we put here. So of the 5 choices, we only have, again, 3 remaining. And similarly, this final guy, we cannot put what we put here, and we cannot put the color that we put here. So the 5 choices, we only have 3 choices remaining for this guy right here. And therefore, the total would be 5 times 4 times 3 times 3 times 3, and that is 540. So that would be D for this question. The infinite product evaluates to a real number. What is that number? All right, so let's write this out. So 10 to the power of 1/3. I'm going to write it out in terms of the fractions. So that'll make it easier. And then multiplied by 10 to the power of 1/3, all to the power of 1/3, multiplied by 10 to the power of 1/3, all to the power of 1/3, all to the power of 1/3, and you guys get the point. So this kind of keeps on going. So this is 10 to the power of 1/3 plus 10 to the power of 1 over 9. Oh, sorry, multiply, I should say. Times 10 to the power of 1 over 27, and so on. So you remember exponent laws. You add them. So it'll be 1/3 plus 1 over 9 plus 1 over 27, ... Now this is an arithmetic or geometric? I believe it's geometric, right? Because it's a ratio. A geometric series. So the infinite geometric series, the sum is 1 over 1 minus r, where a is the first term. In this case is 1/3. And r is the common ratio. And in this case, it looks like the ratio is 1/3, because every time you're multiplying by 1/3. So there we go. So this looks like 1/3 over 2/3, which is 1 over 3 times 3 over 2, which is 1/2. So there we go. This is basically 10 to the 1/2. And that would actually is root 10. So that basically is A. On Halloween, 31 children walk into the principal's office asking for candy. They can be classified into 3 types. Some always lie, some always tell the truth, and some alternate between lying and telling the truth. The alternators arbitrarily choose the first response, either a lie or the truth, but each subsequent statement has the opposite truth value from its predecessor. The principal asked everyone the same 3 questions in this order. Are you a truth teller? Are you an alternator? Are you a liar? And 22, 15, and 9 answered yes. How many pieces of candy and all did the principal give to those who always tell the truth? All right. So these responses we'll have to create into an equation. The truth tellers I will call T. The liars I'll call L, and the alternators I will call A. So the ones who always lie are these guys. The ones who always tell the truth are the T's, and the ones who alternate are A's. But then we've got 2 types. We have the alternators that start with a yes and then say no. And then we have the alternators that start with a no and then say yes, because we're not sure which lie they, or what answer they give first. Okay, so the 22, that can be made into an equation. 22 would basically be T plus L plus some of the alternators. We don't know which ones, right? Because are you a truth teller? If this person tells the truth, they would say yes, right? That's these guys. If they're liars, they're going to lie and say, yes, we're truth tellers. So that's these guys. And then the alternators, some of them, the reason I put some is because we don't know, are they saying yes first or are they saying no first? So that's why I put some A. Now the next equation would be equal to 15, and that's basically people who are asked, are they alternators? Now that, of course, some of the alternators would say yes to that. We don't know which ones are the ones that are saying yes first or no first. But then, of course, all the liars, because the liars are liars, but they're going to lie and say, oh yeah, we're alternators, even though they're not. And then the last one, are you a liar? That one is a 9. And that one, I'm not sure if we even need that one, so I'm just going to leave that blank for now. I think we're just going to work with these 2 equations. If you subtract them, you get 22 minus 15 on that side, and on the other side, you just get left with T. So T is basically equal to 7. So that means that 7 students always tell the truth. And that's basically what they wanted. So that's choice A for this question. How many ways are there to split the integers 1 through 14 into 7 pairs such that each pair, the greatest number, is at least 2 times the lesser number. All right, so we want to create a situation where we have pairs like A, B, and one such example is 2, 5. So according to the question, the greater number, which in this case is 5, is at least 2 times the lesser number. The lesser number is 2, 2 times that is 4, and 5 is indeed greater than 2 times that 2. So that's just one example. So basically we want a situation where B is at least 2 times greater. So B is greater than 2A. Greater than or equal to, right? Because it could be equal, I believe. Okay, so let's work through this. Let's list all the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so let's talk about this now. Okay, so when I'm going to start with this half, because we've got to find a way to place the big numbers first, and then all the other numbers sort of match, I guess they pair up. So let's start with the 8 first. So the 8, that can pair with pretty much anything from 1 to 4, right? Because the number, I can't put a 5 because then 8 wouldn't pair with it. It wouldn't hold this property. But it can pair with anywhere from 1 to 4. So we've got, in terms of choices, we've got 4 choices for the 8. Yeah. Because it couldn't pair with any of the bigger ones because then the property wouldn't hold true. This one right here. All right, so let's keep going. The 9 can pair with also anything from 1 to 4, and therefore we have 4 choices there. But we've already used one choice here, whatever we choose. So it's going to be 4 minus 1, which is 3. All right. 10 can pair with anything from 1 to 5. But we've already chosen one number here to pair with the 8 and one number here to pair with the 9. So those two numbers are gone. So we have to subtract from the first 4, 2, and then we have to add 1 for the 5, right? Because the first 4 numbers, 1 through 4, one of those has already been chosen to pair with the 8, and one of them has already chosen to pair with the 9. So from the first 4 numbers, we've already taken away 2, 1 to pair with the 8, 1 to pair with the 9, and then we've added the number 5 as a new number that can pair with the 10. So that's why this plus 1. So 4 minus 2 plus 1, and that's 3. Okay? All right, so this is the system we have to go through here. Okay, now we're up to 11. 11 can pair with, very similar, I think, 1 to 5. And then now, of the 1 to 5 numbers, we've already chosen one number for 8, one number to pair with 9, and one number to pair with 10. So those 3 choices are gone. So from the 5 numbers here, we have already chosen 3, so that leaves only 2 left. You got it? And then for 12, 12 can pair with anything from 1 to 5. Right? It can pair with anything from 1 to 6, but I just want to write 1 to 5, make it less confusing. And from the numbers 1 through 5, which is 5 numbers, we've already chosen 4 to pair with the 8, the 9, the 10, and the 11. But then we have to add the 6, right? Because then it can also pair with the 6. So that's what this plus 1 is for. So that basically gives me 2 possible choices for the 12. Now the 13 can pair. We actually only have one choice left at this point. Yeah. So we only have one choice left because 1, 2, 3, 4, 5 numbers have already been chosen And from this group. So there's only 2 choices left. So 1 goes for the 13 and 1 goes for the 14. Yeah. And that's it. I think that's it. So multiplying, we have 4 times 3 times 3 times 2 times 2 times 1 times 1. So 4 times 3 times 3 times 2 times 2. Well, the ones you don't really need. Well, you can put them in there if you want. And this all would be 144. So 144, which is choice C. There you go.